So today we are moving to the third part of inverse trigonometric functions. Before that, let us consider the graph of sin x. So here you have the graph of sin x. You know the domain of sin x is the whole real number r, but here we are considering in closed interval minus 2 pi to plus 2 pi. It can be extended to both sides, as you know. Now, let us verify whether sin x is a function or not. To verify whatever the graph is given is a function, the most easiest way is vertical line test. That means you draw vertical lines. Consider a vertical line. So here is a line. You can see that that line intersects the graph at a single point. That means for that value along x-axis, it has a single image, which is the definition of a function. Consider another vertical line. Here you have that vertical line also intersects the given graph at a single point only. Take another line. Again, you can see that a single point of intersection. Here also a single point of intersection. Finally, again we have a single point of intersection. Therefore, here you take any number of vertical lines. Clearly, all those vertical lines will intersect the graph of sin x at a single point. Therefore, we conclude that sin x is a function. Now move to inverse trigonometry. See, the graph of sin inverse x. Is sin inverse x a function? Let us see. You consider a vertical line. Here is a vertical line. Very clearly, that vertical line intersects the graph of sin inverse x at more than 1 point. That means for a single value in the domain, it possesses so many images. Therefore, it is not a one function. Instead, it is a many one function. It has, when we use a vertical line, it possesses so many images for a single point, which violates the definition of a function. Therefore, sin inverse x is basically not a function. You can see that not only sin inverse x, all the 6 inverse trigonometric ratios are basically not functions. But the name of the chapter itself is inverse trigonometric functions. So how we are defining inverse trigonometric relations as a function? Let us see the next graph. What I am doing is I am restricting the graph of sin inverse x at a particular interval, taking minus pi by 2 to plus pi by 2. Now here also let us carry out the vertical line test. Here is a vertical line. It intersects the graph at a single point. Here also a single image is there. Here also we can see that a single image. For throughout this restricted graph of sin inverse x, you consider any number of vertical lines, you can see that it is a function because it intersects the graph at a single point only. Therefore, to define inverse trigonometry as a function, we have to restrict it at some part. Such parts are known as principal value branch. So I am discussing here only sin inverse x. You can go for all the 6 inverse trigonometric functions. Now the principal value branch for different inverse trigonometric functions are given here. That of sin inverse x is closed interval minus pi by 2 plus pi by 2. Other than this branch is known as principal value branch. Other than this, you can find many such intervals which are known as value branches. At all such intervals, it can be defined as a function. The next one can be closed interval pi by 2, 3 pi by 2. Then closed interval 3 pi by 2, 5 pi by 2, etc. But the given interval closed minus pi by 2 to plus pi by 2 is known as principal value branch of sin inverse x. That of cos inverse x is closed interval 0 pi. Principal value branch of tan inverse x is open interval minus pi by 2 plus pi by 2 under the condition that at x equal to pi by 2, tan is not defined. Cot inverse x, open interval 0 pi, sec inverse x, closed interval 0 pi except the value pi by 2 because sec pi by 2 is not defined. Similarly, the principal value branch of cosec inverse x is closed interval minus pi by 2 plus pi by 2 minus set 0 because at x equal to means that theta equal to 0, cos 0 is not defined. So take care. You have to by heart all these things, all the principal value branches of given function. Now let us see where this can be applied. The property is that sin of sin inverse x, sin of sin inverse x means trigonometry is an outer function and inverse trigonometry is an inner function. You can simply cancel. A function cancels with its inverse. Sin inverse will cancel directly resulting into x for all x. This can be applied when trigonometric function is the outer function, right? But when inverse trigonometric function is the outer function, sin inverse of sin theta, here also you can cancel inverse function with the function. Sin inverse sin is equal to theta. You can cancel only if that given angle theta is an element of principal value branch. Here I am discussing sin inverse, therefore theta must be an element of closed interval minus pi by 2 to plus pi by 2. If it is cos inverse of cos, then that theta should be an element of closed interval 0 to pi. That is what here it is shown as sin inverse of sin theta is equal to theta only if theta is an element of principal value branch. Let us go for some application. Let us consider to evaluate sin inverse of sin of 2 pi by 3. Here you can see that inverse trigonometric function is the outer function. Then we are not able to cancel directly the function and inverse, but before that you have to inspect whether the given angle is an element of principal value branch. So how we are solving is sin inverse of sin 2 pi by 3. The angle 2 pi by 3 is actually it is 120 degree, right? It is, I mean, it is 120 degree. 120 degree is not an element of principal value branch of sin inverse, which is closed interval minus pi by 2 plus pi by 2. Therefore, to solve this equation, we should have some adjustments. See how the adjustments are made. Sin inverse of sin of 2 pi by 3 is equal to sin inverse of sin that given angle 2 pi by 3 is split as pi minus pi by 3. It is actually 2 pi by 3. See the next line, sin inverse of sin of pi minus pi by 3. That angle pi minus pi by 3 is an angle in second quadrant in which sin is positive. Therefore, sin of pi minus pi by 3 is restricting to sin pi by 3. Now again we have inverse trigonometry as outer function. Sin inverse sin pi by 3. Can you cancel sin inverse and sin? Go to inspect the angle. Given angle is pi by 3, which is 60 degree, very much inside the principal value branch, minus pi by 3 plus pi by 3. Therefore, by the property, we are cancelling sin inverse and sin, resulting to the answer pi by 3. Therefore, the given question is solved to pi by 3. Go for one more example. Here is the question for that. Let us evaluate cos inverse of cos of 7 pi by 5. 7 pi by 5. Here the inverse trigonometric function given is cos inverse, whose principal value branch is closed interval 0 pi. Now let us see cos inverse cos of 7 pi by 5. How we can solve this? Here is like that. Cos inverse of cos 7 pi by 5 is equal to cos inverse of cos. The angle 7 pi by 5 does not lie in the principal value branch. Therefore, we are adjusting 7 pi by 5 as pi plus 2 pi by 5. Now you see the angle pi plus 2 pi by 5. Pi plus some angle is an angle in third quadrant. But in third quadrant, cos is negative. Therefore, see the next line. It is cos inverse of minus cos 2 pi by 5. That minus is resulted by because that angle lies in third quadrant in which cos is negative. Now here is the line for us. Cos inverse of minus cos 2 pi by 5. Here we want to apply a relation. Cos inverse of minus x is pi minus cos inverse x. Therefore, we are rewriting the last line as pi minus cos inverse of cos of 2 pi by 5. Again you inspect, can you cancel cos inverse and cos? Yes, we can cancel because the angle 2 pi by 5 is an angle inside its principal value branch closed interval 0, pi. Therefore, next line will become pi minus 2 pi by 5, which is 3 pi by 5. In such a way, keeping up the principal value branch, you can solve all the similar questions.